So Ryzen 7 blew us away. 8 cores, 16 threads, single thread within a few percent of Intel.
And the price is very, very low.
Then Threadripper comes along with double the cores, double the threads, similar clock speeds by jamming 2 Ryzen dies into the same socket. The performance is basically undiminished. But they've gone even further with EPYC, an avalanche of 32 cores, 64 threads. CPUs are now getting core counts that are beyond what many of us had imagined. Using smaller dies increases manufacturing yield, which keeps costs low on AMD's end. So Zen is getting great yields. 14nm lithography has matured very well, and GlobalFoundries, the foundry that produces Zen dies, has worked very closely with Samsung to improve both GlobalFoundries and Samsung's yields and defect density for all of their 14nm products. If AMD were to build larger dies or larger CPUs out of a single monolithic die, the yield would probably drop down to 60% or lower, which would bring up price. Using the same blueprint for every CPU in their lineup is useful in another way. If AMD wants to produce more of one of their lines, Ryzen, Threadripper, or EPYC, then all they have to do is ramp down the other two and ramp up production in the one that they want without changing anything at the foundry level because they all use the same dies. So Intel has made public comments deriding AMD for their use of glue to hold their CPUs together. And while AMD has proved that their architecture can hold its own weight in spite of this glue, it brings up a very interesting topic, that of AMD's Infinity Fabric. Every CPU has some sort of interconnect between cores and uncore devices like memory or PCIe controllers. Years ago, both AMD and Intel used the same interface for this, called frontside bus. When frontside bus began to show its age in 2001, AMD switched to a technology called hypertransport. Intel, on the other hand, continued to make the best of frontside bus until about 2008, when they unveiled their current solution, Quick Path Interconnect. AMD took hypertransport through several revisions and finally abandoned it in favor of Infinity Fabric, which debuted with Ryzen earlier this year. The challenge when putting multiple dies into the same CPU, like we see with Threadripper and EPYC, is making sure that those dies talk to each other very quickly. Infinity Fabric is AMD's chosen solution for this problem in Ryzen and all future technologies, and many credit it as the secret to their success in the CPU arena, especially in servers where we see single-socket EPYC trading blows with dual-socket Xeon systems. Infinity Fabric is also more adaptable than AMD's previous technologies. Maurice Steinman, who has a very long title, said that Infinity Fabric is agnostic on topologies and will also be implemented on Vega as a mesh. This means that a dual Vega card would be natively possible, except for the fact that you'd need an industrial transformer to power it. But in the future, potentially with Navi, AMD could create a simpler GPU building block, like they've done with the simple Ryzen dies, and stitch several together to create GPUs that are easier to design and cheaper to manufacture. NVIDIA has already published some of their own research on this topic, indicating possible intent to pursue this technology with GPUs following Volta. So that's it for this one. You know how the like, dislike, and subscribe buttons work, so I'll leave you here and see you next week.